Hello and good morning everyone. So my name is Muhammad Faris bin Umayyah and my partner is Muhammad Imran Shukri. So we will do analog electronic lab 2. The name is operational amplifier using anti-spice. So let's have 5 configuration. First inverting, second non-inverting, third integrator, fourth differentiator, and fifth summing amplifier. So the introduction is the operational amplifier produce an output voltage that is proportional to the difference between the two input terminal. In this lab, 5 OPM configuration will be investigated. So we will go to the inverting first. So this is circuit schematic for inverting amplifier. So it's have R1, R2, VIN, and OPM amplifier at M741. So for R1, value for R1 is 1K, R2 33K, and VIN is setting in sign 0, 1, and frequency 1K. So let's run. So I will click to the VIN. So this is our waveform for VIN. And then I will click to the output. So this is the output waveform for Vout. So in the calculation, I use voltage gain equal R2 over R1. So 33K over 1K is equal negative 33. So for Vout, I use calculation AV darab Vin. So negative 33 darab 1 equal negative 33 volt. So in this for the experiment, I will plot the value. So I got 13.97. It's not equal like calculation. Is it because the voltage setting in 50 volt, but amplifier just can only use 40 volt. Plus refer to the datasheet of LM741. Second, the question is what is it called inverting amplifier? Is it because inverting amplifier output signal has the opposite polarity or phase of the input signal? Second, I will go to the non-inverting amplifier.
I show you circuit D, non-inverting. So this is my circuit. I use R1 1K, R2 10K, and for source, I use sign 0, 1. The frequency is 1K. So I'm using OM LM741. For source at positive and negative terminal, I use 15 volt. Okay, I run. So this is my input signal, and this is my output signal. The output signal is 11 volt. Sama dengan saya punya calculation, V out equal to AV times V in. So voltage gain I get 11 times 1, so 11 volt. So question 3, why is it called a non-inverting? Because the source connected to the positive terminal. What does non-inverting mean if a sine wave is connected to the operational amplifier positive terminal? First is the output is not invert relative to the input. So for the voltage gain, always positive and greater than 1. Okay, that's all. Thank you.
So this is let's see integrated OP amplifier. So this is R2, R1, V in. I use pulse and this is for setting. So OP amplifier LM741. So I will run. So I will click to the V in. And then I will click to the V out. I will zoom. So this is for waveform for V in and below is waveform for V out. So in the calculation is V out equal 1 over 0.01 micro darab 100K integrate 1 Vp. So I will get calculate equal negative 1 volt. While in this waveform Vin, I got negative 1 volt. Negative 1 volt. After that, result for experiment for V out. I got 2.87. So the question is not the 10 mega resistor is not in the ideal integrated circuit. What is it therefore? First, it will definite DC gain. Second, OPM imperfections. Third, output restoration. And the second question is describe what would happen if a small DC component was present in the input waveform. the DC component will continue to increase until the output voltage reach the maximum possible limit. That's all for me.
Okay, this is for circuit D differentiator of amp. Okay, first I set the source to the bus V on step 1, time delay 0.1 micro, time rise 0.0005, time fall 0.005, T on 0, K period 0.001. Okay, I run. This is for input. This is for output. So we will get the V out equal to negative 1. So for the question is note here that the 100 picofarad capacitor is not in ideal amplifier. Why do you think if it is there? First, the 100 picofarad capacitor is add to the practical op-amp amplifier circuit to ensure that the circuit is stable and doesn't oscillate the high frequency. For question 8, what will happen to the output waveform if the input Vin is increased to maximum value? When the input voltage is too high, the output waveform of the op-amp will be clipped or flattened of the maximum voltage limit set by the power supply. A condition is called saturation.
So this is the circuit schematic for summing amplifier. Let's have two OP-amp, still same that LM741 and positive Vin connect with second amplifier. So I will run the circuit. First I will click in the VSOT Vin. So this is the waveform for Vin, and then I will add Vout. I will click to the Vout, and this is for waveform for Vout. So the calculation is Vout equal 10k over 10k darab 1 plus 10k divide 2k darab 1 and equal to negative 6 volt. So in the experiment, we click the cursor and mention is so in this I will get negative 5.98. It is like similar like negative 6 if we mudahkan. So the question is what do you understand about summing amplifier? So this the summing amplifier have two or more voltage are connected to op-amp. Second, RF resistor connect the output inverting terminal is a feedback. First is the input. So the second question is explain what happened to the output if the frequency of the source is increased to 3k Hz. So the output of summing amplifier will likely decrease in amplitude and may begin to show distortion.
Okay, for the conclusion is we successfully demonstrate the characteristic of operational amplifier configuration, confirm the close alignment between theoretical and simulate the voltage gain values and quantify the effect of non-ideal components such as capacitor, bypass resistor, and offset voltage on the circuit output. Okay, that's all. Thank you.